Hey everybody, thanks for joining me. Today we're going to practice real numbers, and this usually leads to number lines. It usually leads to square roots, rational, irrational, what's the difference? There's a lot that goes into this lesson, so I want to make sure we get to it pretty quick. All right, the first four, find the number in each list that has a whole number square root. So basically that's saying which of these numbers is a perfect square. What number has a whole number that can be multiplied by itself to give you 7, 18, or 25, looking at the first example. Now, I'm not going to spend a whole lot of time going through these first four because I have a feeling that you guys have practiced this quite a bit at some point in your life. 7 is not a perfect square. There is not a number you can multiply by itself to give you 7 or 18. Well, there is, but it is not a whole number. And that's kind of what we get at when we practice our real numbers. So 25 is pretty clearly what we were looking for there, so let's just go with it. 119, 120, and 121, what I'm hoping is that this is sort of refreshing your memory a little bit. 121 was the one I was looking for because 11 times 11 is 121. That's sometimes one that gets forgotten. A lot of times people will learn 10 because 10 times 10 is 100, or they'll learn 12 because 12 times 12 is 144, and people just seem to remember that one. But 11 sometimes gets lost in the shuffle there. 0, 10, and 20, just to throw you off a little bit, the answer is 0. 0 times 0 is 0. And so sometimes people think that the square root of 0 can't be done, but that's not true. The square root of 0 is 0. All right, last example, 61, 41, 21, 1. How about 1? That's another one where people tend to forget that 1 is a perfect square, because if you drew a square that had dimensions of 1 by 1, the area of the square would be 1. All right, on example number 5, now you see that symbol there. That symbol is actually not a square root symbol technically. It's actually called a radical. And this actually does matter. The reason why is because if you were asked to find the square root of 49, technically there are two of them. And the reason is 7 squared gives you 49. But technically negative 7 squared is also 49. So technically 7 and negative 7 are both square roots of 49. So that gets kind of confusing, you know. How does that work? How can I remember to do that? Well, the good news is when you see the symbol, when you see the actual radical symbol like you have right up there, it means you don't have to worry about negative 7. It means all you have to do is write 7 as your answer. You don't have to worry about negative 7 at all. So that's good news. It kind of makes things a little bit easier to sort out. So that's a technicality, but it's probably something that you should know. I honestly didn't learn it until I was 21. So if you can beat me to it, that would probably be a good thing. All right, example number 6. When you're taking the, when you have a fraction under a radical, all you have to do is take the square root of the top number and then the square root of the bottom number, and you are good to go. And again, because it is a radical symbol, it's only referring to the positive square root. You don't have to worry about the technicalities with the negative 3 over 7 or the positive 3 over 7. All you have to do is say 3 out of 7. Now, example 7, again, people get lost on this one sometimes, but the square root of 1 is 1, and the square root of 100 is 10. And again, you don't have to worry about positives or negatives. All right, you get down here, and this is kind of mean to make this all one example, but you know, apparently it was just a mean creation of mine, so I guess we need to just get through it here. Is 31 a perfect square? Is there a number that goes that multiplies by itself to give you 31? The answer is yes, there is a number that does that, but it's going to be a pretty funky looking decimal. Here, let me make a cameo here with this really cheap calculator that they give you on these computers. Yeah, that's not pretty. It's going to go on forever. kind of like me when I teach sometimes, which makes this number irrational. An irrational number goes on forever. So, in the case of this radical 31, it is irrational. Now, the good news is it is real. I mean, there was a number that made it happen. It went on forever, but there is a number. In fact, all three of those on the list are real. Now, most of you know that when you see a bar over a number, it repeats. So, for instance, what you have right here is 31.33333333. And so people, a lot of the time, just assume that this is going to be irrational as well. Well, I'm going to tell you right now it's not. It is rational. And the reason why is that a rational number is anything that can be written as a fraction. And the reason that digit is repeating is because it at one point was a fraction. To prove it, we'll bring in the cheesy calculator again. If you were to do 94 divided by 3, you would get 31 with a repeating 3 at the end. That's what we're talking about. So whenever you see a repeated decimal, it's really tempting to say, hey, this is an irrational number. But that's not true. It just means it was being divided over and over and over again, which means at one point it was initially a fraction. So that's a trick one. That's why I put it on the examples, because I want to make sure that you get a chance to get it explained to you. All right, last but not least, 31. Well, 31 is just, well, it's natural. I mean, that's a pretty standard counting number. It is an integer. You could write it as a fraction if you wanted to be 31 over 1. So all of these things apply, but again, it is not irrational because you're either one or the other. All right, place these on a number line. So you've got radical 11, so we can make the cameo here, and we can say radical 11, 3.3. It's about 3.3, give or take. So that means that's going to go right about there. I mean, this is going to be one of those things that it's not going to be perfect, but you're going to do the best you can. 7 over 2. Now, I would like to think that you know that that's 3.5. So I'm just going to work off of that, and I'm just going to assume you know that, and I'm going to put it right about here. I'm going to kind of run out of room, so I apologize. So I'm just going to put it right up here, 7 over 2. 4.1, that's going to be just a little bit past 4. And last but not least, you've got a radical here, and it's 81 over 16. So you have to do the square root at the top. You have to do the square root of the bottom. And then 9 over 4 is, well, 8 over 4 is 2. So 9 over 4 would be 2 1/4, which you could put right about here. So if you had to put it right there, it would be right about there. So from least to greatest, you would have 9 over 4, and then radical 11, then 7 over 2, and then 4.1. So that's how they would look on a number line. So just be careful, because a lot of times people make silly mistakes. All right, last but not least, insert an inequality symbol. What is the square root of 78? Well, you can probably tell that it was going to be a little bit less than 9, because the square root of 81, radical 81 is 9. In this case, radical 78 is 8.83, which looks to me like it came out slightly bigger than 8.7. So when I am inserting an inequality symbol, I am going to make it greater than the 8.7. So the way you would officially read it would be 8.7 is less than radical 78. All right, I hope that helps. Good luck the rest of the way.